I'm going to discuss today is the F-test. The F-test is the analysis of variance, or ANOVA. This is used in comparing the means of two or more independent groups. One-way ANOVA is used when two variables are involved, the column and the row variables. The researcher is interested to know if there are significant differences between and among columns and rows. This is also used in looking at the interaction effect between the variables being analyzed. Then for the steps in ANOVA, okay, so first is of course to state our problem. Then second is to determine the null and alternate hypothesis. Then find the sum of squares for the total, between, and within. And these are the formulas that we are going to use. The next is find the variance estimates, that is the mean squares, find the F ratio, and complete the ANOVA test. Then for our example, a sari-sari store is selling 4 brands of shampoo. The owner is interested if there is a significant difference in the average sales for 1 week. The following data are recorded. So these are our average sales for the 4 brands of shampoo. What are we going to do? Perform the analysis of variance and test the hypothesis at 0.05 level of significance that the average sales for the 4 brands of shampoo are equal. So, for our problem statement, is there a significant difference between the average sales of shampoo? Then, for our hypothesis, the null hypothesis is there is no significant difference between the average sales of shampoo, or it can also be expressed as HO is equal to mu1, or is mu1 is equal to mu2 is equal to mu3 is equal to mu4. Then, for our alternative hypothesis or alternate hypothesis, there is a significant difference between the average sales of shampoo, or HA is mu1 is not equal to mu2, is not equal to mu3, is not equal to mu4. Then for the level of significance, we are going to base our hypothesis testing at 0.05 level of significance. For the degrees of freedom between, we have their k minus 1. This k, this represents the number of groups we have. So here we have 4 groups. Okay? So 4 minus 1 is equal to 3. For the degrees of freedom within, we have their n, that's the total number of values we have, minus the number of groups k, that is 28 minus 4, that is equal to 24. And then for the degrees of freedom total, we have their n, the total values minus 1, we have 28 minus 1 is equal to 27. Or it can be, we have the degrees of freedom between plus the degrees of freedom within, that is also 27. Then, for our computation, okay, we need to compute for the sums, okay? The sums for A, B, C, and D. We need to get the sum of A, the summation of A squared, A bar, and then NA. Okay? Then we also need summation of B squared, B bar, and B. Then, summation of C squared, C bar, and C. Then we also need the summation of D squared, D bar, and D. Okay? So, for the summation of A, okay, that is 37. Summation of A squared, we have 225. A bar, or the mean of A values, or the values for group A, we have 5.29. And then for NA, the number of values, we have 7. For the summation of B, we have there 57. Summation of B squared, 475. B bar, we have 8.14. And B is 7. For the summation of C, we have there 26. Summation of C squared, we have 110. For C bar, or the mean of C values for C, group C, we have 3.71 and we have there NC is 7. For the summation of D, we have there 36. Summation of D squared, we have 204. D bar, we have 5.14. And ND, we have 7. The next, we need to compute for the summation of X total, that is equal to the summation of A plus summation of B plus summation of C plus summation of D. We have there 37 plus 57 plus 26 plus 36. Summation of X total, that is equal to, we have 156. For the summation of X squared total, we have there the summation of A squared plus the summation of B squared plus the summation of C squared plus summation of D squared. We have here 225 plus 475 plus 110 plus 204. Okay? So we have here summation of X squared total, that is equal to 1014. Okay? The next is, let us compute for the sum of squares total. That is equal to the summation of X squared total minus the summation of X total squared over N. So we have here the summation of X squared total is 1014 minus 156 squared over 28. Okay? So this gives us 144.86. Okay? The next is, let us compute for SS between. For SS between, that would be summation of A squared over NA plus summation of B squared over NB plus summation of C squared over NC plus summation of D squared over ND minus the summation of X total squared over N. So for SS between, we have 37 squared over 7 plus 57 squared over 7 plus 26 squared over 7 plus 36 squared over 7 minus 156 squared over 28. That is equal to, what is our SS between? 72.29. Okay? The next is for the SS within. SS within is equal to SSA plus SSB plus SSC plus SSD. Okay? So for SSA, we have there the summation of A squared minus summation of A squared over NA. That is equal to, we have 225 minus 37 squared over 7, which gives us 29.43. Okay? So for SSB, we have there summation of B squared minus summation of B squared over NB. That is equal to 475 minus 57 squared over 7, which is equal to 10.86. Okay? SSC is equal to the summation of C squared minus the summation of C squared over NC, which is, what is our summation of C squared? We have 110 minus 26 squared over 7, which gives us 13.43. SSD is equal to the summation of D squared minus the summation of D squared over ND, which gives us 204 minus 36 squared over 7. That is equal to 18.86. Okay? Then, we can now get the sum. Okay? So, we have their SS within is equal to the sum of SSA plus SSB plus SSC plus SSD. Or SS within is equal to 72.58. Okay? So, next is we can now make our table. We have for the first column, that will be the sources of variation. The next is the sum of squares. The next is the degrees of freedom. The next is the mean squares. Then the F ratio, or the computed value of F at 0.05, and then our decision. Okay? This is for our table. Okay? So, the first row, okay? For the first row, this will be for the between. Then this will be for the within, the second row. And then we have here our total. Then for the sum of squares between, okay, we have 72.29. And then for the within, we have there 72.58. For the total, we have 144.86. Then for the degrees of freedom, we have here 3 and 24, and this is 27. For the mean squares is equal to the sum of squares divided by the degrees of freedom. So for the mean square within or between, we have there 72.29 divided by 3. It gives us 24.097. And then for the within, we have there 72.58 divided by 24. We have there 3.02. For the F ratio, that is equal to the mean squared or mean square between divided by the mean square within. And that gives us 7.97. So for the F at 0.05, okay, we are going to get this at or in your table at the back of your book. The last table at the back of your book on page 306 to 308. Okay? So, as you can see there, we have 2 entries per cell. The upper entry is the level or the tabular value at 0.05 or the critical value at 0.05, and the lower entry is the critical value of F at 0.01. So what we need is F at 0.05. So for the F at 0.05, we have there for the degrees of freedom between, that is 3, that will be for the column, and for the within, that will be for the row. Okay? So we have there 3 and 24. It gives us a tabular value or a critical value of 3.01. So again, for the decision rule, we have there, if the computed value or if the F ratio is greater than F critical value, we reject HO. Okay? So that only means that it is beyond the critical value that belongs to the critical region. Okay? So for the conclusion, okay, so since F ratio that is equal to 7.97 is greater than or beyond F at 0.05 that is equal to 3.01 with 3 and 24 degrees of freedom, we reject HO. Here, we reject HO. That only means that there is a significant difference between the average sales of shampoo. Okay? So, we have concluded that there is a significant difference. But where does the difference lie? Okay? So, can it be in product A, or product B, or product C, or product D? So, let us compute for that by using, the Scheffe's test. The F-test tells us that there is a significant difference in the average sales of the 4 brands of shampoo. But as to where the difference lies, it has to be tested further by another test. That is the Scheffe's test. Okay? So, this is the formula that we're going to use for the Scheffe's test. We have there F prime is equal to the mean of group 1, or the first group that we're going to test, minus the mean of group 2 squared, divided by the mean squared, or the mean square within, times n1 plus n2 divided by n1 times n2. Okay? So, for our example problem, okay, so let us conduct the Scheffe's test. So first is, let us compare the product A or group A, product A versus product B. So we have here F prime 1 that is equal to, for the mean of A that is 5.29 minus the mean of B that is 8.14 squared divided by the mean square within, we have there 3.02, okay, times NA plus NB, that is 7 plus 7 divided by NA times NB, that is 7 times 7. So it gives us 9.401 or 9.4. Next is, let us compare A versus C. We have there F prime 2 that is equal to, what is the mean of A? Again, 5.29 minus the mean of B. We have mean of C, that is 3.71 squared divided by 3.02, the mean square within, times NA plus NC, that is 7 plus 7 over NA times NC, 7 times 7. That gives us 2.89. For A versus D, okay, let us compare A versus D. We have F prime 3. We have there 5.29 minus, what is the mean of D? We have 5.14 squared divided by 3.02, the mean square within, times 7, that is NA, plus 7, that is ND, over 7 times 7, NA times ND. So that is equal to, we have 0.026. F prime 4, or we compare B versus C. We have there, B bar is 8.14 minus C bar, that is 3.71 squared divided by the mean square, we have 3.02 times NB, that is 7, plus NC, we have 7 over 7 times 7, that is NB times NC. And that gives us 22.714. The next is, we have B versus D. We have F prime 5. We have there 8.14 minus, what is the mean for D? 5.14 squared divided by 3.02, mean squared within, times 7 plus 7 over 7 times 7. That's NB and ND. That is equal to 10.417. The next is C versus D. Okay? We have their F prime 6. That is our mean for D. We have our C. We have 3.71 minus the mean for D. We have 5.14 squared divided by 3.02. The mean squared within times 7 plus 7 over 7 times 7. We have there 2.37. Okay? The next is let us create or let us make our table. We have here our sources of variation. And then we have here our F prime ratio or the F prime. Okay? Then we have here our F at F prime at 0.05. So how are we going to get this? F prime at 0.05 is F at 0.05 times K minus 1. So this is equal to, we have 3.01 times 4 minus 1 is 3. We have 9.03. Okay? Then we have here, okay, of course, our remarks. Okay, sorry for this. We have here okay. So for the sources of variation, we have A versus B, then A versus C, then A versus D, then B versus C, then B versus D, and then C versus D. Okay? For our computed values of F prime, we have 9.401. A versus C, we have 2.89. And A versus D, we have 0.026. B versus C, we have 22.714. B versus D, we have 10.417. And then C versus D, we have 2.37. F prime at 0.05, we have there 9.03. Okay. Okay. Then, just like our decision rule, if the F computed or the F prime computed is greater than F prime at 0.05, then that means it is significant. Then if it's less than, then it's not significant. So in the case of A versus B, this is F prime ratio is greater than F prime at 0.05. This is significant. For A versus B, that is not significant. Not significant. We have here significant. This is also significant. And this is not significant. So, we have here our A versus B, B versus C, B versus D. Those are the significant F primes. So, from this, what is common? So, we have there B. So, the difference lies where? At brand B. Okay? So, that's all.